Today we are going to see lesson number 18, that is search to find the smallest number. So here, as you can see in the picture, there are different squares displayed, and out of these three squares we have to find out which is the smallest one. So obviously you will tell me, yes, the square which is at second position is the smallest shape in the given shape. So what are the steps exactly behind this? How we are deciding this, that is the particularly square at the second position is the smallest one. So what we have done, we have compared square at the first position and square at the second position. Within that, this is square at the second position is the smallest one, and whatever the result we got, with that result we have compared a particular square which is present at third position. So there also within that comparison we are getting particular square, that is the square at the second position is the smallest square. So as you can observe, there are three number of squares and we are making only two comparisons. Now let us see the algorithm for this. Step 1. Let x equal to the first number in the list. Suppose there are n numbers in the list, then out of that first number we have to consider, or we have to assign first number in the list to x. It will be the x. Step 2 will be move from second number in the list till the end of the list. We have to start from second number of the list till the end of the list and follow the following steps. So in that first step is compare the content of x with the number at the current position in the list. It means whatever the value we have assigned to the x, with that x we have to compare the value at the current position in the list. It means we have to compare the value from the second position in the list. If the number at the current position in the list is less than the content of x, then x is equal to number at the current position, else move on. Means while checking the condition, if the number at the current position, it means if the number at the second position in the list is less than the content of x, then x is equal to number at the second position, else we have to move on the next. Step 3 will be, if you have reached at the end of the list, x contains the minimum of the given number. Means while doing this, if we have reached to the end of the list, then automatically we will get, or whatever the value will present in the x will have minimum number, that is the smallest number in the list. Let us see example. So as it is given in the algorithm that we have to consider first number in the list as a x. So as you can see, there are 10 different numbers in the list, that is 24, 35, 17, etc. So we have considered first number to x, and from second position we are comparing the value. Now at second position 35 is the number and we are checking with x. Is 35 is less than x? No. So x will be as it is. Move on the next position, that is third position 17. We will check with the value of x. Is 17 less than x? Yes. So if yes, our particular step is, if the number at the current position in the list is less than the value of x, then we have to assign number at the current position to the x. That's why we are assigning 17 to the x. That's why we are getting x is equal to 17. We will move on the next position. Is 63 less than x? No. So x will be as it is. On the next position, is 37 is less than x? No. That condition is false. That's why x will be as it is. Is 56 less than x? No. That condition is also false. That's why x will be as it is. Next position's value is 42. Is 42 less than x? 42 less than 17. That condition is false. That's why x is equal to as it is. Next position's value is 6. Is 6 less than x? That is 6 less than 17? Yes, condition is true. That's why we are assigning a value which is at current position, that is 6, to x. Now we are having x is equal to 6. Move on the next position, that is 71. Is 71 less than x? Condition is false. That's why x will be as it is. Next position's value is 84. And here again we have to check whether 84 is less than x. The condition is false. That's why x will be as it is. We cannot change that x. And here we are getting x is equal to 6. That is, it is the smallest element in the list. So here we have made 9 comparisons for 10 elements. So always keep in mind, if there are particularly n number in the list, then we have to make n-1 comparisons in the list to find the smallest element from the list. Thank you.